Soft collision of two objects is inelastic. The main purpose of this presentation here is to show that if, for example, two objects collide together, and if the collision is soft, it means if both becomes one object after the collision, then maybe both moving in one direction, then this type of collision is inelastic. The aim of this presentation is to show that if two objects collide and if they merge and become one object after the collision, in which this type of collision we name it here soft collision, then this collision is inelastic. We will make it clear what exactly we mean by inelastic shortly, no matter what their masses and velocities before the collision. Simply here, let us assume that there are two objects with masses m1 and m2 moving with velocities before collision. We name them u1 and u2. For simplicity, we can just assume they move both in the same direction, but definitely the same object can be concluded if both are even moving opposite to each other. Here, for simplicity, definitely it has to be obviously assumed u1 is greater than u2 so that the collision can occur. Then after collision, both objects now have become one object and both moving with velocity v. Then in any collision, there are few facts in which before we start the analysis, we need to be aware of it. There are two principles normally we talk about. One of them is called conservation of momentum. Here, momentum we assume as, or we denote as a letter little p. So p, the momentum before collision, is equal to p, the momentum after collision. The second principle in which usually we talk about in any linear collision is conservation of kinetic energy. So it means kinetic energy before collision is equal to kinetic energy after collision. So make sure that we are not talking about anything else in terms of energy apart from the kinetic energy. And the inelastic collision, certainly here, both principles are holding. So it means momentum is conserved and kinetic energy is conserved. But in inelastic collision, only conservation of momentum, which is p, holds, not both of them. Now we start the analysis. The analysis here simply the conservation of momentum of both before collision and after collision leads to this simple equation m1 u1 plus m2 u2, which is simply the left hand side of the equation is momentum before collision, is equal to momentum after collision. So because m1 and m2 have become one object, so for simplicity we combine them as one single m1 plus m2 times v, the velocity after collision. Simplifying this equation here, v is the subject, becomes this expression m1 u1 plus m2 u2 divided by m1 plus m2. Now the kinetic energy. So conservation of kinetic energy, definitely here we have put a question mark in contrast to the conservation of momentum. Conservation of momentum holds, but conservation of kinetic energy, we do not know if it is true here or not. And simply here, to illustrate, we assume that there is a question mark. Kinetic energy before collision, is it equal to or not equal to the kinetic energy after collision? Although the main aim of this exercise is to show that they are not equal to. So it means simply we need to show that kinetic energy before has to be greater than kinetic energy after in these types of collision. The expression of kinetic energy before collision is half m1 u1 squared plus half m2 u2 squared, which is certainly fairly easy. And kinetic energy after collision is half m1 plus m2 times v2 v squared. Then at the start, by looking at these two expressions, there is a way in which we can easily say if they are equal or not. Now, the next job here is, let us assume that we simplify the expression. So it means we drop the half out just for simplicity, and then the expression takes this format. And again, here we can even simplify it further. We can multiply both sides of the expression by m1 plus m2 just to make the expression simpler. And then by multiplying and expanding m1 plus m2 times this expression here, you will get this expression to the left, and the same type of multiplication and simplification, you will get this expression to the right. Certainly, if you look at these two expressions, m1 squared, u1 squared from both sides are the same, so we can cross it, and m2 times u2 squared from both sides are also the same, we can cross it. Then later on, we divide both sides of the equation by m1 times m2 for simplicity here. Then you will have these two simple expressions, u1 squared plus u2 squared. And to the right, which is certainly kinetic energy or something after scaling, we could say kinetic energy after collision is 2u1 u2. Then if we use this fact here, a minus b, the whole squared, is always greater than 0, which is true in simple algebra, then this can easily lead to the fact that kinetic energy before and is greater than kinetic energy after. So it means kinetic energy then it doesn't hold. So it means if it doesn't hold, these types of expressions or these types of collisions are then inelastic. Thanks for listening. Thank you.